The scene model from Meta allows you to scan the environment with your headset and use that information to build a mixed reality game. In this previous video, I share with you how to use it in Unity with the OVR Scene Manager, but now Meta has released a new tool called the MR Utility Kit, which not only allows you to access the same data, display custom plane and volume like before, but also helps you to debug the scene in the editor, get details about the specificity of the room, and even easily place object. So in this video, let's dive in and learn how we can use it. As always, make sure to subscribe down below, and if you'd like to get access to the source code of this tutorial and more exclusive content like a mixed reality multiplayer game, join us on Patreon, the link is in the description. But without further ado, let's get started. Okay, so here we go, we are inside Unity, and as you can see, I've already downloaded the Meta all-in-one SDK. I've already added an OVR camera rig to my scene and added the path-through to see the real world around me. Now, just to show you, if I click on build and run, and there we go, as you can see, I'm inside the application and path-through is working. You can see my desk and this beautiful baguette that I will be able to eat after this tutorial. But now the big question is, how can we use the scene model for this app, specifically with the MR Utility Kit? And let me show you how to. So the first thing that you want to make sure is to go on the OVR Manager, make sure that Quest 2, Quest Pro and Quest 3 are all enabled, then to set the tracking origin type to floor level. And here for the scene model, of course, you need for the scene support, set it to required, as well as for the pass-through required as well. Then down below, make sure that you enable path-through, and for the permission request on startup, make sure that scene is enabled, and with all this, the scene model should be able to load inside your application. Next, with these settings, we can add the MR Utility Kit by searching on the project for MRUK. There you go. Here, make sure that for search, you are setting it to all, because otherwise it will not show. And there, we can simply drag the MRUK over there in the hierarchy. Now, as you can see, this is just an empty game object that only has one script over here, right there. And the only thing that are set up on this script is here some room prefab that I will be able to explain just later. But now, if you click on play, as you can see, we have this thing which just appears when we click on play. And you can see that there is some wool that seems to be placed all around, a floor, a ceiling, but of course right now nothing is showing, because indeed with the MRUK we were able to launch the room and to spool for the room walls, floor and ceiling. And by the way, as you can see, all of these objects have on them an MRUK anchor, which represent the different elements on our room, but these elements are not visible yet. So let's fix this. Let's leave play mode, and I'm going to search this time for the effect mesh. There you go, you should see it over there, and we can drag it as well. And now, as you can see, this component will track that a room is spawning and will add a material to it. And the material in question is here the room box effect, which if we click on it, has a nice highlight shader that I will be able to show you right now. If I click on play, there it is. As you can see, we can now finally see the scene model. It has displayed the scene for different parts of the wall. We have here a door, we have here some furnitures. Now, by the way, as you can see, this is not my real scene model, the one that I've personally set up with my Quest headset. The reason is that for some reason right now it doesn't seem like you can properly use your scene model within the Unity editor, so you actually need to build your application to test the one that you have created. Now I think they will fix it, because it used to work this way before with the OVR Scene Manager. But what's really cool is that if you go to the MRUK, you can see that we have as a data source the device with prefab fallback, which means that if there is no data that is found inside your Quest headset, it will instead load one of these pre-made scenes for you, which is super handy if you want to, in some case, debug and test your XR game with different configuration without having to redo it with the Quest 3 headset. So for example, if I leave play mode and that I click play again, you can see here a completely new configuration. And of course, these all are random, but you can basically add your own on the room prefab over there, or even you can set the room index to one in particular, And in the case that you don't want this prefab fallback, you can simply set the data source here to simply device. But now if we have a look at the effect mesh, we can see that there is also a setting here for colliders that will add colliders to all of our anchors. So let's enable it. Beautiful. And if I click on play, there you go. If I select one of the elements, you can see that for each of them, there is a collider that has been added, which is super cool because it means that now we will be able to interact with our real world and collide with it. So if you guys remember, on this first tutorial that I made on how to make a Quest 3 mixed reality game, I show how you can do this. And in the second episode, we were even able to spawn little sphere that will collide with our real world. And here, this will be exactly the same with already what we've done. So to speed things up, we can go under the right-hand anchor, and I'm going to add here the spawn ball script that were made inside these old tutorials. So you can see this is a very simple script that will simply listen to the player's secondary index input, and if the players press on this button, it will instantiate a ball and give it an initial velocity. Okay, so here I will drag here this sphere prefab under the spawn ball. This means that it will be the prefab that will be instantiated. And now let me go to File, Build and Run to show you what it looks like. Oh, and by the way, something that I've noticed is that on the effect mesh, make sure that for the labels, you have the global mesh, which is disabled, because the global mesh is the complete mesh that has been created when doing the scene model. But we simply want here not the global mesh with all its little details, but the main element of it, like the walls, the floor and stuff like this. So yeah, let me go back to File and click on Build and Run. And there you go, guys. As you can see, everything seems perfect. We have the effect mesh working in real life. And if I press on the secondary index trigger, as you can see, we have a ball spawning that collides with the floor and the walls. This is really cool. Okay, so with the MR utility kit, we can even go further than this, because right now with the effect mesh, we can display some stuff and colliders for every anchors of our scene. But what if we only want to do this for some particular element? So let me show you. We can simply right click, go to create empty and call this one scene anchor spawner. We can add component and add a anchor prefab spawner script. And as you can see, this script, when the current room is loaded, we'll be able to load some prefab. So if I click on the plus button here, you can see that you can say the labels. So on which label you want to add the prefab. And you have even some setting here to scale the prefab according to the size of your feature. So for example, let me simply right click, go to create empty, call this one wall. We can reset its position at 0, 0, 0. And I'm going to right click on it, go to 3D object, cube. This will create a cube, as you guessed it. And on the Z axis, I'm going to set the Z scale to 0.01. Beautiful. And now we can drag this wall as a prefab in our project and remove the one that we have in the hierarchy, because now with the scene anchor spawner, if we click on the plus button for the prefab and drag our walls, and that for the labels, we will be able to spawn this prefab for each label that we set over there. So let's try this, for example, for the floor and for the wall face as well. Now let me show you. If I click on play, there it is. As you can see already, in a matter of a few seconds, we were able to make this work. And as you can see, the prefab that we created, so the wall prefab, is now spawned on the scene model anchor. And you can even see that its size is adapted to the good size, which is really cool because it means that now with the scene anchor spawner, you have a total control of what you want to show. So for example, in my case, I'm going to leave play mode. For the effect mesh, I'm going to disable the colliders over there. And for the scene anchor spawner, for the wall here, I'm going to simply go on the prefab. And here for the cube, simply disable the mesh renderer. This case, if I click now on play, as you can see here with the prefab spawner clone, I will only have colliders for the wall and the floor with the prefab that we just spawned. And there it is. So these are already two things that we learned, the effect mesh and the scene anchor spawner. But now I want to tell you more about some tools that you can do with the MR utility kit. Because have a look at this. This is awesome. With the mixed reality utility kit, you can not only display the scene model feature, but you can get all crucial information about the room. For example, here you get the key wall, which is the longest wall in the room. You can have some raycast to find some collision point. That does not use colliders, by the way. You can have some position in the room. You can try to get the closest seat. So all kind of stuff, which I think is amazing. Now, just to give you an example, I'm going to go back to our project and I'm going to make a very simple script that will simply display the label of the current room we are pointing at. So for this, let's right click, go to create empty, and I'm going to call this one display label. We can reset here its position, and I'm going to create a new script with this name, display label. Beautiful. This script will be very simple. We are going to need at the top to write using meta.xr.mrutilitykit. And so, as I just told you, my goal with this script is to cast a ray from my player's end and to get some information about the anchor that we are pointing at. So for this, let's add at the top a public transform called ray star point, a public float called ray length that we can maybe set to 5. And now with these two information, we can already create a ray by doing ray equals new ray and give our ray start point the position for the starting point. And for the direction, we can do ray start point dot forward, which means that the ray will have the direction of the blue axis of this transform. Now that we have a ray, we can already cast this ray by doing MRUK dot instance. So this will get the current instance of the MRUK script. And we can get the current room with get current room. There you go. This will get us the current MRUK room, which we can store in a variable called room. And with this current room, we can cast a ray by doing room.raycast. And as you can see, the parameters that this function needs is first the ray that we just made. Then we can add our distance for the ray, which will be ray length in our case. And then we can do out raycast it. So here by writing out raycast it, this will output here these parameters, which will tell you some information about the raycast. For example, the collision point and the normal of the point we just found. But we can even go a bit further than this. For example, as you can see, we can add some label here to filter the anchor that we want to find. So just to give you an example, if we go at the top, we can do public MRUK anchor dot scene label and call this one label filter. Beautiful. And we can give these parameters like this with label filter dot from enum and give our label filter over there. And finally, there is another parameter that we can add at the end, and it is the out MRUK anchor. And there it is. With this beautiful line of code, we are able to cast a ray from our player's hand position with this ray length that will filter this anchor and which will give us as output two things, the hit position and the anchor information. This is beautiful. So let me show you, for example, how we can use them. For example, we can write bool has hit equals to this all things, because this all thing will return true if we hit something and false if we have not. So it means that if we have found something, there it is, we can do something with it. Now, in my case, I'm going to go at the top and simply add a public tmpro.textMeshPro debug text. So my goal here is to simply have a text as a parameter, and the text will be able to show the label that we just hit with the ray. And to do so, we can get first the hit point by doing hit.point. Then we can even get the hit normal with hit.normal. And we can even get as a string the label with anchor.anchor labels. And here, as you can see, this contains a list of strings, but in my case, I simply want the first one, which we can get with the 0 over there. So that's it. Now with this, we can simply set the debug text.transform.position to be the hit point, the debug text.transform.rotation to be a rotation that look in the direction of the normal. And finally, we can set that the debug text.text, so the text that it displays, will be anchor plus here the label that we just found. And there it is, our beautiful script is finally down. We can save and go back to Unity. Okay, so for the text that we simply want to display, this is very simple. Let's right click, 3D object and go to text mesh pro. This will create a huge text that we can see here, and that maybe we need to scale a bit down like this. Yeah, I think that a value of 0.04 will be good on all axes. Beautiful. Now, if I press on T, we can try to scale it on the two sides, and we can even maybe center the text over there. We can put it in italic and even yellow to make it a bit more beautiful. And we can rename it debug text. Beautiful. Now, as you can see, there is a little issue with it, is that the forward axis, so the blue axis of the text, point in the opposite direction of when we are reading the text. So what we can do actually is to go back to our script, and here for the rotation that we want to give to this text, we actually want it to be the opposite direction of the normal that we hit. So we simply need to write a minus over there and everything will be fixed. So there you go. Beautiful. Now we can go to the display label and drag our debug text over there. For the ray start point, we can actually go to our OVR camera rig, and I want the ray to start out of the right hand, so I can drag it there. And for the label filters, I'm going to simply set it to everything but disable the global mesh. There you go. Now with everything down, let's try our game. And there it is, guys. As you can see, it works. When I try to move my controllers, it correctly shows the different anchors that we have. We have, for example, here a table, over there a wall, here we have a floor, and everything seems to work. This is amazing. And as you can see, the text is always displayed with the good rotation and at the good position. So right now, what actually blows my mind is that with the new setup that Meta has done, it automatically can label things for you. So for example, it has recognized that this is a storage and this is a table. Now, this is really cool, I think, because it will allow us to do so much more things as XR developers. And there you go. So this is an example at how you can use some of the features from the Mixed Reality Utility Kit. Now, remember that there is plenty more. So if you want, you will be able to find the link to this documentation in the description below. But before leaving you, I want to show you one last thing. Because right now with the MRUK, you can actually have some tools for object placement. So let me show you. If I right click, go to create empty, call this one spawn position, we can reset the position over there and add as a component a find spawn position script. Now this script, as the name suggests, can find some spawn position in the scene model for you. So just to give you an example, we can take the ball from earlier and I'm going to duplicate it and call it floor ball. And we can even remove here the rigid body and the sphere collider. But make sure that the position is at 0, 0, 0 for this prefab. It will be very important for the find spawn position script. Next, we can drag this floor ball over there on the spawn object. And now, as you can guess, this will spawn the floor ball by the number of spawn amount time inside our scene models where we want it to be. So for example, we can go on the spawn location and here we can set it instead of floating to any surface to spawn the ball on the surface itself. And for the labels, in my case, I simply want the ball to show on the floor. So I'm going to select it over there. And now if I click on play, there you go. As you can see, the ball has spawned 8 times where it was possible. Now, as you can see, this scene model was a bit hard because there is a lot of stuff inside it. So it shows you how it really works. And by the way, as you can see, it takes also into consideration the bounds of this prefab. So basically the size of the prefab to offset it in position and make sure it's not inside the floor, but positioned correctly. And there you go. Now you can have so much fun with this prefab. Now you can do a lot of things with this component and spawn all kinds of objects in all kinds of places. And I guess that this sums up the last thing that I wanted to show you in this tutorial. We learned a lot of things, the effect mesh, the scene anchor spawner, how to display information, and how to spawn objects. Now, if you want to learn more, there is actually some pretty nice sample scene made by Meta, which you can find by going to Windows, Package Manager, and if you go to the MR Utility Kit, which you can find in your project, there is here the samples that you can download. and that will give you plenty more information. And I guess that with this, it will give you a lot of things for your own mixed reality game. Now, I hope that you enjoy these tutorials. As always, if you did, please make sure to leave a like and subscribe down below. And if you want to support this channel and get access to more tutorials and exclusive content, like how to make a mixed multiplayer application, join us on Patreon. The link is in the description. Thank you for watching and see you very soon. Bye bye.